Hello, my name is Louisa Monahan and I'll be doing problem 15.8, Practice with a Hypothetical Reaction Mechanism and Reversible Substitution. The problem reads, consider the overall reaction which is experimentally observed to be second order in X and first order in Y. X plus Y goes to XY. Does the reaction occur in a single step in which X and Y collide? And B, is this two-step mechanism valid? First, let's go over the equation that we'll need for this problem. The rate law equals K times the concentration of each reactant with an exponent of their order. The reaction is experimentally observed to be second order in X, which means that if it was a single collision reaction, there would be a coefficient of 2 in front of the X, but there is not. Therefore, there must be multiple steps of the reaction. If the reaction was a single step with second order in X and first order in Y, it would need to look like this. 2X plus Y goes to X2Y. Now let's strategize for part B. Is this two-step mechanism valid? The requirements for a valid multiple-step mechanism are that the elementary steps must sum to the original equation and the predicted rate law equals the observed rate law. If we cross out the elements listed on both sides of the equation, we are left with the original equation of X plus Y goes to XY, which means that the elementary steps do sum to the correct equation. The observed rate law for the problem is second order in X and first order in Y. Now let's find the predicted rate law. The first step is to determine the rate-determining step of the reaction, which in this case is the second step because it is the slowest. The rate law for the second step would be K3 times the concentration of X2 times the concentration of Y. However, the reaction that produces X2 is reversible. If the rate-determining step is not the first step, a step above is fast and reversible, and a product of the first reaction is a reactant of the rate-determining step, then we must substitute. This means we must replace the concentration of X2 with K1 over K2 times the concentration of X squared because of the coefficient of 2 in front of X in the first step. This gives us the new rate law of K prime times the concentration of X squared times Y, which would explain why X is second order and Y is first order. Therefore, yes, the two-step mechanism is valid. Now let's review. The answer for part A was no, the reaction has multiple steps because second order implies there should be a coefficient in front of the X. For part B, we concluded that the two-step mechanism is valid because the elementary steps sum to create the original equation, and the predicted rate law equals the observed rate law, which is K prime times the concentration of X squared times the concentration of Y. Thank you.